We're best in class is where we fit in. We're a specialist manufacturer of consumer products, of audiovisual products. But within that sphere, within that category, we strive to always be differentiated by being best in class.
We've always tried to bring some key ideas to our products. One is that music is absolutely important. So the sound has to be true to the real thing. We're not trying to make an artificial sound. We're not trying to manufacture a kind of sound. With Meridian, we're trying to reproduce the original recording really as accurately as possible.
We have, for a long time, used programmable DSP in a lot of our products, many of our products in fact. And as more time has gone by, we've added more value to our products and increased the performance of our products by making better use of that programmable DSP.
We've been conveniently designing by putting certain processing, digital processing of all kinds of signals, into convenient boxes, and then we bolt the boxes together.
Our programmable DSP has been a complex animal to deal with. Often multiple devices, often devices which are programmed in different ways by different engineers, different subsets of our development and engineering team involved on those different elements, and then having to bring them together is complex, time-consuming, and as a result expensive. The attraction with the XMOS technology is to be able to bring all of those things together in a single device.
So what attracted us specifically in terms of the application was the ability to integrate a number of functions into a single chip that we needed for a particular design without barriers. That's obviously possible at a very high capital cost. Design your own chip, go down those routes. It's also possible at a very high piece part cost with a large FPGA. But where we have XMOS, we have a scenario where the barriers to entry are not there, and its ability to perform a number of disparate functions that would normally require several chips really helped us out. Well, XMOS helps us in that ambition by allowing us to build systems that are simultaneously high performance and efficient in other ways. In other words, it's quite easy to build a low performance device that is small and has low power consumption and meets all the EMC regulations and all of these things, and is flexible in its design. You can do that, but if you want to do it where you have certain performance criteria, what you then have to do is say, what chips will allow us to develop that, what componentry will allow us to do that. And that's where XMOS comes in, because it has a very high level of capability combined with the ability to do that in a single chip, which frankly is at a reasonable cost.
So as soon as we saw the XMOS part, we thought, right, we're going to run a few things up the flagpole. And we implemented 3 or 4 things, and very quickly came to a rather shattering conclusion, which is that this is a startup company, and we think we want to put this chip in everything we make.
The first board is the initial design that we did, which just consisted of a microcontroller to do some of the communications and the ability to transmit on the digital audio that's coming from the PC motherboard that's in this product with some buffering. This is functionally effective, but it uses the digital audio coming from the motherboard, which has a couple of properties. One is that it is rather jittery, and another is that you have to use the clock speed that's coming off the motherboard, which tends to be a bit inaccurate. We found the performance of this board to be inadequate for our purposes, or even though it's very cheap and simple. We then said, how do we fix that? We added to it the ability to receive USB audio, and that required us to add a complex programmable logic device, and a digital signal processor and a couple more bits of glue chips to do upsampling. And we ended up with this rather clumsy, expensive solution. But then we realized that with the XMOS we could go back down to, in fact, a 4-chip solution, but one of those is just the small memory to store the program for the XMOS device. We still have one of the interface chips, but then we have the XMOS doing all of the signal processing, and in fact the other 2 chips, one is just a clock generator, and this one is simply the memory that stores the program for the XMOS. So this illustrates very well what XMOS does, which is it gives you high performance at the same time as low component count.
We've got the XMOS chip now in, I think, 4 products shipping. Yeah. And we're about to introduce, 1 a month for the next 6 months that use this chip exactly for the reasons that I described, that it is extremely effective and efficient. We can control its power, and it does the things that we want to do that otherwise would take 3 or 4 or 5 chips and not be as effective in either in time or as controllable in the processing.